All right, we are going to deep dive into the different phases, and we'll start with the enablement. Okay, in the enable phase, I've covered this in detail in the that slide itself. So I'll quickly run through the things that is mentioned here, and then we will quickly see the kind of options that we have. That's going to be really interesting. So there are 4 pieces to enablement. First is the orchestrator deployment, whether it's going to be the on-prem or on-cloud, disaster recovery, high availability, what is the kind of scalability that is required in this particular things. For example, you have 700 robots today, you have to scale up to 900. What is the kind of strategy that you are going to apply and things like that. The second is the robot deployment. When we say robot deployment, it pertains to the operating system that is going to be used. It pertains to the prerequisites that is required for running your subsystems, systems that is going to be used for your processes. All the prerequisites are maintained. Are met or not. Even the robots have some kind of prerequisites in terms of hardware requirement and the software requirements and things like that. We have a couple of options, so you have to decide what works best for you, whether you want to have it on a VDI, VM, or whether you want to have a cloud-based option for these things. And how are you going to scale up, whether you have a couple of robots that's there that can be connected at times of peak loads so that it can be taken up and the process runs smooth. Package deployment is another concept that we have to be really familiar of. The package that is, there are certain packages that is officially provided by UiPath, right? And when I say package, these are something that controls your activity that you see in your activities pane in the studio. So there will be at times when you are going to develop your own packages, or you will be getting something from marketplace. So let's suppose that you took something from the marketplace, and this is something that has been developed by one of the community owners. And although there is a lot of security runs and static checks that happens within UiPath before releasing it to the marketplace, sometimes you want to double check and make sure that everything is okay, so that you are able to propagate it to further projects in your environment. The next one is credential deployment. So you must have a strategy of how you are going to store your credential, right? So we have credential stores attached within Orchestrator that you can use. You have your Windows credential managers. You have, as a last resort, you have your get password activities that will basically obscure all your password, and then you can that gets converted to secure string, and then you can use that. So you have to have those kind of strategies in place so that it's quite clear how these kind of things are going to be managed. I'll just add that maybe it's a good idea to have a strategy around your sensitive data around clients as well. Something that you want to think of, that if there are certain kind of sensitive data from the clients, how you are going to deal with those things as well. Coming to the first part, the deployment ones. Maybe probably the simplest deployment options that we see is something that will look like this. We have multiple robots that is going to be deployed. It is going to talk to the orchestrator, which is a web application, and then there are a persistent layer in terms of a SQL server backing the orchestrator, and an optional Elasticsearch, which is going to store all the log details. Okay, and here I want to mention that although the logs gets into the SQL server, if you are not opting for Elasticsearch, it's probably a good idea to have an Elasticsearch in place if you have a lot of robots and a lot of logs that is being generated. The reason being, the performance can get impacted if there is huge amount of logs that are being generated by the robots. Maybe a couple of robots might not impact so much. You can survive with the same SQL Server strategy for a year or so. But if you have, like, let's say hundreds of robots and they are generating over 100 MBs of logs in a day, so you'll quickly start bulking up the SQL Server. And bulking up of SQL Server is not a good thing to do. And you might overrun in terms of performance, and you might need to rethink your strategy. So it's a good habit to have Elasticsearch, which is basically designed to handle the logs. It's kind of like an indexing server, wherein you have all these logs dumped into pages, and it uses a index search mechanism within itself, so that you can have a conversation with your logs if you want. And when I say conversation, I'm talking about Kibana, where you can have these dashboards get created. So I also want to highlight that probably when you are testing, or probably when you are doing a POC, it's okay to have the complete Orchestrator SQL server in a single server. In the same server, you can place both of them. But when you're going live, and maybe in the production environment, it's a good habit to keep them separate. And the whole idea is, again, coming down to the same thing, that performance is impacted if you are utilizing the same computing power for the SQL servers and the web servers as well. If you go on the docs.uipath.com, you will get a detailed picture in terms of architecture, how the application layers looks like, where the REST APIs goes, what are the kind of ports being used to have conversation, where the WebSocket is formed, and things like that. We are not going to deep dive there, so you can have those reference from the documents. The second option is high performance and high availability. So the one that you saw right now is good enough to handle maybe 700 robots. So one single robot is enough for maybe 700 robots. But then again, there are at times you face challenges with processes that cannot go down at any cost. There are tight SLAs around it, or maybe there are certain other requirements that makes your robots to be always available, kind of like a critical requirement. In that case, we will go ahead with high performance and high availability kind of a setup, wherein your robots are being handled by a distributed system of Orchestrator. If you see on the screen itself, you have a node balancer, which helps in allocating the robots to particular orchestrator in the diagram. And the network load balancer have a round robin algorithm that is running within itself. So it's kind of like an equal distribution between the orchestrators. And the orchestrator then have a persistent layer in terms of SQL Server, and the SQL Server will be running on a SQL Server always on availability group, which is something that splits the SQL Server into two parts: the primary data and the secondary data part, and it manages on itself. So if, for example, one goes down today, the data from the other one will be utilized to back up the orchestrators. And if both are up, it will be based on the load that is there, that one will be up and the other one will be backing up, and maybe the switch will happen once the other one goes down, and once that's up, maybe the backing happens the other way around. The next one is the load balancer connection to the Elastic servers, and I'll have to specify that this is another interface of the same load balancer that we have used for communicating between the orchestrator and the robots. And this node balancer talks with the Elasticsearch nodes. And if you see here, we have the Elasticsearch nodes split into 3, and I'll talk about this in a bit, why it's being done. And the other thing that I want to talk about is the Redis. So Redis is your in-memory databases. Okay, so it's nothing but an in-memory databases, and it deals with your robot connections and user sessions that are being created. Okay, so when you connect a robot, you know that there is an associated user session that gets started, and the connection is also there. So there is a storage mechanism that is there for it, and that is what Redis is used for. And this is also split in the same way. You have a master Redis that is controlling between these particular Redis distributions. And here also you see that there is three of the Redis instances, and here in the Elasticsearch also you see 3 of them, one denoted as master data, 2 denoted as master data, and 1 denoted as master. And now why it is done in this way is to avoid a split brain problem. To give you a brief about a split brain problem, what happens is, for example, if there is only master data and master data environment, right? As in, like, we have only two nodes, both denoted with master data, master data. So for example, one acts as a master and the other one is acting as a data at the moment. Master becomes the primary one and the data becomes the secondary one. So it starts to taking the copy of it, while this one serves the request that is coming in. So for example, the master goes down, right? The role of the data is to take over the role of the master. So the data becomes the master in this case, right? This goes down, this was the master, this takes over, this becomes the master themselves. Okay, now this one is master, right? And now the connection was lost, this became the master, and it is starting to distribute whatever the data is coming in. Okay, and this one, while it was denoted as a master itself, when it comes back online, it'll assume that the data is lost, because there is a direct connection with the orchestrator to this particular data, which is now acting as a master. And this master will see that there is no request that is coming into it, and there is no data that is available, so it will still sit idle. So basically, if the next thing happens is that this is in isolation, this is in isolation, if this goes down, there's a breakage of connection. So, and the second one is your Redis connection. So this split brain problems, wherein every single node, even though that was designed to have as a master data kind of combination, splits into master kind of a thing, is called a split brain problem. And the same scenario happens here if we have just two. If one goes down, the other one assumes that he is the master, he takes over all the requests, and the other one, when comes back up, although because it was designated as a primary master, will assume that there is no request and there is no data available. So it'll sit in isolation doing nothing. So to avoid that, we have a distributor that is assigned to it, that, okay, just make sure that when the master is up, he is designated as master again, the other one lowers his permission to the data ones, and everything goes smooth. Okay, so this was high performance and high availability setup. The next one is disaster recovery option. When we talk about disaster recovery, you must be aware that it's a good strategy that if one of your setup is in, let's say, northern hemisphere, keep the other one in the southern hemisphere. That's kind of like a thumb rule that is said. So for example, one of your centers are in Australia, and if you want, if it's kind of like a very critical thing that you're doing, and you want the other one to be sitting somewhere in North America, for example. And why is it important? Let's take example of the California fire that happened recently, okay? And imagine your data center being there in California, and it got impacted by the wildfire that is there. It went down, right? If you don't have an option to start a backup of whatever was running, you will be lost. There is nothing that you're running. All the processes are down. You don't know what to do. There will be a haphazard situation. That's why it's called disaster recovery. One of your so this is a active passive setup. One of your setup is an active setup wherein you run all the things, all the robots in place. This is the same high availability architecture. And the other one, something that is designated as a disaster recovery setup, will be sitting on the other side of it. So if you see, the setup looks very similar. Apart from that, this always on availability group is the primary and the secondary data, instead of residing in the same data center, has been split between two. One is the primary data center, the other one is the secondary data center. Other one is in the disaster recovery data center. So whatever data is being there, it is being copied here, and it is waiting for its turn. Once this goes down, somebody will switch it on, and it will have the same copy of this one, so that everything is in place. Similarly, for the Elasticsearch part, there will be a snapshot. So Elasticsearch has a snapshot and a snapshot recovery tool. So basically, you can take a snapshot periodically of the Elasticsearch and put it somewhere. And there is a tool that is provided by Elasticsearch from where you can recover these kind of snapshots and have it available in another instance wherever you want it to be. So we use that particular concept. The snapshot is taken and put it in an external storage. in the disaster recovery data center, and same goes for the package paths. So whatever the deployments have happened for the processes, for the custom activities, libraries, things like that, all those packages path will be also stored in the external storage, and this will be configured wherever that is being stored will be configured as a NuGet package path for the orchestrator that is residing here. So in this particular setup, the restore mechanism will happen here, and the Elasticsearch will get live once that is required. So in this particular setup, once primary data center goes down, somebody will go in and switch on the secondary data center, and everything that is here is basically a copy of this. It's kind of taking a snapshot periodically. It is taking a backup of the persistence activity, and the orchestrator also has all the feeds with them. The robots will be configured with this particular orchestrator instance. So once switched on, it will start behaving as a normal robot, and it will resume with all the activity that is there. Meanwhile, the primary data center can take its time to recover from whatever is happening. Disaster recovery is something that is going to be critical for an enterprise-wide RPA that is going to be deployed. If it is a really small thing that is going to happen, I assume that the business will not be investing much in those processes, right? So these kind of solutions is something that should be in place, to be honest, because if a process is critical, you have to have a mechanism to keep it running, right? But if it is really small, this is something that can be handled by the team that is sitting there. If the process goes down for some days, it can be handled by them. But if it's an enterprise-wide solution and there are a lot of processes that are running using these kind of setups, that is when your disaster recovery comes into picture.